Can you tell me what is the meaning of life and display it on screen? Let's go. 42. Oh my god. zclaw says the meaning of life is 42. I knew it. I knew it, guys. Ever since the explosion of OpenClaw, the internet has been flooded with all sorts of lobster-themed AI agents. PicoClaw, NanoClaw, IronClaw, ZeroClaw, TrustClaw, and even NanoBot. Okay, that last one is not really a lobster, but you get the point. And amongst all of these claws, I think I've stumbled upon the smallest one of them all. It's called zclaw. It's an OpenClaw equivalent specifically made for microcontrollers like the ESP-32. And it's incredibly tiny. The entire firmware budget is just 888 kilobytes. But despite that, it offers the same agentic AI features as its bigger brothers, but it runs on a $5 chip instead of an $800 Mac Mini. In this video, we're gonna take a look at what zclaw is capable of, how to install it on your own hardware, and then we'll test it out with a fun little demo. It's gonna be a lot of fun, so let's dive into it. So zclaw advertises itself as the smallest possible AI assistant for ESP-32 microcontrollers with an all-in firmware budget of just 888 kilobytes. It's built on top of the ESP-IDF development framework, and it ships with a ready-to-use networking stack that supports Wi-Fi, along with a TLS and crypto stack and a certificate bundle with app metadata. This allows the tiny ESP-32 to talk directly and securely to HTTPS endpoints, like chatting with your AI model through a Telegram chat without exposing your keys to an unencrypted middleman. And since it's built on the ESP-IDF framework, you can add additional drivers for your IoT sensors or custom firmware plugins to augment your assistant's capabilities. I even managed to successfully pair it with my circular TFT display for the demo you will see later in this video. But what is the actual use case for this tool? Well, first of all, zclaw has full access to your microcontroller, so you can use it for reading GPIO and sensor pins, monitoring health checks, and you can also ask it to do scheduled tasks like setting a blinking LED status reminder whenever it's time to water the plants, or like scheduling a recurring equipment check for your system. And all of this is done by chatting with your AI agents through a messaging app like Telegram, where the ESP-32 acts as a client. The LLM processes your prompts on the cloud using your chosen AI provider, and the logic execution happens locally on the chip. And since the ESP-32 has a limited NVS or non-volatile storage, you can type something like, "Remember that GPIO 4 is my door sensor," and from that point on, zclaw will store these mappings in the local storage, and it will know to trigger the specific GPIO pin when talking about door sensors. So all that sounds cool in theory, but now I want to try it for myself on my own little ESP-32C3 microcontroller and see how it performs. First of all, let's flash zclaw onto the controller itself. So let's connect the controller to our laptop via USB-C, and then let's clone the zclaw repo. From here, we just need to run the install script, and the setup is pretty straightforward. It will first ask you to build the firmware, and if this is your first time running the build, it might take a minute or two to finish. Next, we need to flash it onto our ESP-32 by running the flash script. And finally, we have to provision it by running the provision script. And here in the provision step, it will ask you for your Wi-Fi SSID you want to connect to. Then it will ask you to choose an AI provider. It can either be OpenAI, Anthropic, OpenRouter, or Ollama. In my case, I will choose OpenRouter. Next, you will need to input your API key as well as your Wi-Fi password. And at this point, it might say that it has some issues connecting to the network, but don't worry about that. It might still go through when we run it, so just type Y to proceed. And now it will ask you for your Telegram access token. And in order to get this, you have to message the bot father on Telegram to create a new bot for you. Once you go through that process, BotFather will supply you with an access token for your specific bot. And that's the one you have to paste in here. And then it will ask you for your user IDs that are allowed to chat with this bot. And here you need to specify your own ID. But in order to get that, you need to send a message to user info bot, and it will give you back the user ID on the Telegram app. Once you input all of that, your zclaw should be installed and ready to run. We can then execute the monitor script to activate it and see the logs coming in from zclaw in real time. So now comes the fun part. Let's test the actual hardware. So I was planning to do this demo on a normal breadboard setup. I even soldered the header pins on my chip for this purpose, but then I noticed that for some reason, when running the chip attached to the board, it could not reliably hold a stable Wi-Fi connection. Possibly because the metal rails on the breadboard interfere with the Wi-Fi signal. You have no idea how long it took me to realize this issue. But anyway, so instead I had to hook up my chip to these special pin clamps that let me wire them up to the breadboard externally. And for some weird reason, this setup worked perfectly. There were no connection issues and the chip could hold a reliable Wi-Fi connection this way. So next I set up a simple circuit. I've got the 3.3 volt rail powered up and the single LED acting as our status indicator. The anode is tied to GPIO 3, which the zclaw agent will toggle as a digital output. And on the other side, I've got a simple 220 ohm resistor hooked up in the ground rail to keep the current in check so we don't blow out our diode. This is your simple hello world setup for embedded hardware tests. And now comes the exciting part. I can now ask zclaw to activate this diode by chatting with it through Telegram. So with this setup now, I can tell zclaw that this diode connected to the GPIO 2 pin is a light. So I can say treat GPIO as the main light. And you can see that GPIO 2 is now saved as the main light. And it will remember this for future commands. So now I can ask it, turn on the main light. And as I do this now, the main light is now turned on and flashing. So after a few minutes of chatting with zclaw, you soon realize that its capabilities are quite limited. And that's because if we look at the code, it only has a limited amount of tools at its disposal. It can perform read-writes on GPIOs, it can handle basic memory storage operations, address you in a specific persona, and that's basically it. But that doesn't mean we can't add our own tools, right? So for the next demo, I decided to do something more interesting. So I have a GC9A01240 by 240 TFT display here, and I want to hook it up to zclaw and make sure it can display any text that I prompt on this screen. So for this purpose, I modified the code a bit. I added a new tool call in the tool C file that lets me prompt a specific text to display, and I can also specify what color I want the text to be. Next, I asked Claude Code to vibe code the display function for me in a separate C file. And lastly, I added it to the tools handler's header file. And I also needed to add the specific driver for my GC9A01 display as a dependency for the ESP-IDF project. And with those changes, I recompiled the project, reflashed it, and reprovisioned it again. So now I've augmented the original zclaw project with my own custom tool. So let's see if we can get it to draw some text on my display. So for the second demo, the wiring is a bit more complicated, but basically this is just a standard way of hooking up an external device to your microcontroller. I'm not going to go over the whole wiring setup in detail, but if you're interested, you can pause this video here and take a note of the wiring diagram if you want to replicate it on your own. So I have my ESP32 right over here. It's hooked up to my display here. And now I have the Telegram chat open with the zclaw bot. And now I can, for example, ask the bot to display text saying hello world. Let's see what that does. Oh, look at that. It instantly displays hello world on our display. Can you display on the screen how you are feeling today? I'm not capable of feelings like humans, but I'm here and ready to assist with whatever you need. See? The bot says subscribe, so I think you should really listen to zclaw on this one. Let's do a hard one now. Can you tell me what is the meaning of life and display it on screen? Let's go. 42. Oh my god. zclaw says the meaning of life is 42. I knew it. I knew it, guys. So there you have it, that is zclaw in a nutshell. I feel like it's a very fun little AI project to play around with, but for real production builds, I don't really see the point of conducting this agent communication via a messaging app, when in fact you could probably do all of it more efficiently through a custom-built web API interface. But it's a cool novelty concept nonetheless. Now, what would be impressive though is if I could prompt zclaw to write custom code via the messaging app, and then it would immediately compile and execute that newly written code on the controller on the fly. Now that would be something special. If you can figure out how to do that, let me know in the comments down below. And folks, we don't do hardware tutorials on this channel very often, but if you like this one and you would like to see more hardware topics explored in the future, please let me know by clicking that like button underneath the video. This has been Andres from BetterStack, and I will see you in the next videos.